Okay, this is the third video working with partial fraction decomposition. It's advanced in the sense we're working with the idea of repetition, and I've given us a numerator that is a little bit different to be expected. Hopefully this will pop out so that you have seen every possible situation you might run up against. So the number one thing when we're working with repetition, meaning that we have a set that's squared, is that we have to represent it singly and then as that squared value. So as I break this apart, I'll go ahead and stick that single x here in front. And then I'm going to put what's in the parentheses as a single first, so just x squared plus 1. And then I'm going to do him again, this time as x plus 1 squared. Had I had cubed, I would have to do that as a single, squared, and then cubed. And you just kind of build yourself up to that value that way. Then as I put my alphabet on top, it's a single letter, so it's a single here. It's a double, so I'm going to put the bx plus c, a double again, so I have dx plus e. All right, so if you recall, first thing we'd hope for, and I've given that situation, is if we have possible factors, which we do here. I can look at the factor of x equaling 0, but these other two are non-factorable. They would give us actually imaginary numbers. But we've got 1, and that's always good to have at least something. So let's go ahead and draw out just the numerator. So we just have the 1 here from the top. But in order to balance out with having common denominators, this a would need to have the ax plus 1 quantity squared. This bx plus c would need to have one more x squared plus 1, and it would need to have the x. So it's going to have a little bit of combination. And this guy here only needs an additional x. Okay, so I put them up top so that I can stretch them out down here. It's going to make it a little bit easier for us. The other thing I'm going to do too is I'm going to make sure that I remember that when I have a quantity squared, it's best when I multiply it to write it out twice. That reminds me that I'm not actually just squaring two pieces, but I'm going to have to distribute. So I'm going to end up with x to the 4th. When I have a duplicate like that, I'm always going to have double of that value, so 2x squared plus 1. So I'm just kind of making a note of that. That's going to make it a little bit easier because when I write this one out, I'm going to say a, and I'll put that whole times value out here. Like such. Perfect. Okay, and then I'm going to have bx plus c. And then just again, to help myself out, I'm going to go ahead and distribute that x through. And I get x cubed plus x. And then finally here I have dx plus e. And here's my caution. If you just stick an x on the end just randomly, you've created something completely different. It's so important that you put a parenthesis to suggest that it's going to have to be distributed to both. All right, so let's go ahead and test this first one here at 0. So if I put 0 into all of my x's, and that includes these bx's and these dx's and such, I'm wondering what's going to happen here. So that's going to eliminate these two, but it's going to leave me with 1. So I'll do a1 or 1a. Let's go ahead and write it a little more algebraically that way. Equals 1. Bx, that would eliminate this one completely. But if I have 0 plus 0, I have 0 times anything. So this whole set's gone. And same thing here, timesing by 0 would remove that. And that's usually the intent. You're going to find that it will isolate any of those. And so I happen to have a value of a is 1. If I have my little number box area over here with my answer, I can go ahead and put that 1 there over the x. I have a portion of my answer. I'll go ahead and just kind of get this filled out for us. Sometimes it's nice to just see that you're making progress as you're moving along. Okay, so here's my nice answer box. Now, I'm not going to be able to do anything else with that, so I'm going to go ahead and line up. And here's the reason why I picked this, because it has a little bit of a tweak to it. We have a numerator of 1, but I know as I distribute through, I'm going to get even up to the power of x to the 4th. So as I line things up here, I'm going to have to say I have 0x to the 4th and 0x the cubed. So I'm just going to keep descending down until I get to that constant value. So I can put my numerator in position, create my rows so I can organize. So that's a little bit different that way. It's good to see. Distribute the a through to all 3 of these, and I'm going to have ax to the 4th and 2ax squared and an a, which confirms what we already had determined about a. Now, these, put a parenthesis around so you make sure you're actually distributing multiple times. Bx times x cubed is going to give me bx to the 4th. Bx times x, that's another x squared quantity. C times x cubed, so that's going to come over here in the x cubes. And then c times x and a single x. So you can see I'm just kind of matching these up. Final one here is times our x to both, so I have dx squared and ex. Okay, remember the purpose behind this was to organize it. Visually now in each of these rows you can take off the matching values. So I can strike off the x to the 4th with each of these, and I can say 0 equals a plus b. And then I'll continue doing that. So I have 0 equals c. Yay, one more thing I know. 0 equals 2a plus b plus d, and 0 equals c plus e. And I already confirmed that a equals 1. So I can put my c is 0 up here. Essentially, that just means I won't have a c value to add. So I'll just be working whatever I have for b and put that in the numerator. All right, let's do a little substitution here. I know that a is 1, so this is actually going to be 0 equals 1 plus b. If I minus my 1 off, I can say b is a negative 1. So this will complete this one up here, and I'll say a negative x. Again, no c value. There's no point saying plus 0, so that term is settled. C we already know. Here, let's do the same thing with this one. Let's bring him down over here. So I have 0 equals 2 times a plus the b, which was a negative 1, plus d. So I'm going to be able to solve for d now. 2 minus 1 is 1. And if we just minus 1, we know that d is going to be a negative 1. He's the front runner here, so we have another negative x. And then finally, if I put 0 in for c, I get that e is also 0, which eliminates that one. And then there is my solution. So the unique parts about this particular one is repetition. Make sure that if you have that any power, it could even be up to the 5th if you want to, you count up to it. So you go with a single, and second, and so forth. If you don't have but much at all on the numerator, you are going to have to count for putting zeros in front, so I can line everything up to solve for it. But you can see that it just gives me something simple to work with because of that 0. And that is a little more advanced look at partial fraction decomposition.